Hey everyone, today we'll be solving LeetCode problem number 473, Matchsticks to Scare. It's a good question and has been asked to me in the Microsoft recently, and it is based on the backtracking problem. So let's have a look on the problem statement. In this problem, we will be given an integer array, matchsticks. Matchsticks I is the length of the ith matchstick, okay? And we are also given that we have to use all the matchsticks to make one scare. Like mentioned in this diagram, that they have used 1, 2, 3, 4, 5 matchsticks to form a scare. And we are also given that we should not break the stick and you can only line them up, and each matchstick must be used exactly one time. Okay, so let's say if you are using this matchstick in one edge, you cannot repeat it again. And we have to return true if we can make a scare, otherwise return false. Okay, let's try to understand this problem using this example. Here, matchstick is the length of every matchstick. So first two matchsticks are of length 1 and the later 3 matchsticks are of length 2. So in the diagram, they have like a form. This edge is formed using first two matchstick, and later all 3 matchsticks are forming another 3 edges, and they are making a scare. And what we have to return is, we have to return true if we can make a scare, otherwise return false if we cannot make a scare using all of these matchsticks. We cannot skip any matchstick and we cannot repeat any matchstick. Like if one matchstick is used for this edge, we cannot consider it for the another edge. Okay, so first of all, they have asked us to form a scare using these matchsticks, and if it is a scare, it must be of the same edges. Like let's say this edge is of length A, so this length should also be of length A. This is also length A, this is also length A. So what is the perimeter of this scare? 4 into A. So 4 into A is the perimeter. And we are also given that we have to use all these matchsticks. If we are going to use all these matchsticks, that is, we already know the parameter. So parameter is equal to, as per this example, it is 2 plus 2 plus 2 plus 2, 8. So 4 into A is equal to 8. Or you can say 4 into the length of edge is equal to perimeter. So what is the length of this scare? It is perimeter divided by 4. So now we have found the edge. So how we are going to proceed further to make a scare? In this example, we have matchsticks as 1, 1, 2, 2, 2, 1, 1, and 3 matchsticks of length 2. And we have to form a scare, and scare will form like this. There is only one possibility, that one edge is using 2 matchsticks of length 1 and another are using of 2. So all the edges are of same length. It means we have to divide this set, or you can say this collection, into 4 sections. 4 sections whose sum is equal to like a fixed value. If we were given that we can use a specific part of this matchsticks, then it would be something else. But we are given that we have to use all the matchsticks. It means every matchstick will be a part of any length. Let's say this matchstick is going to be a part of this length, and it won't be a part of another length, another edge. So it's clear to us that we have to divide these matchsticks into 4 sections, which will lead to 4 edges of the scare. And if it is being divided into 4 sections, it means every section should have a sum equal to A. Correct? Because total sum was 4 into A, and that is equal to perimeter. Perimeter is, we already know, that is sum of all the matchsticks. So perimeter is not a constant. Perimeter we have already derived by summing all the elements. So we already know the value of A. A is equal to perimeter divided by 4. So we know the value of A. So we have to divide these matchsticks in such a way that those specific collection, or you can say bundle, will lead to the sum equal to perimeter divided by 4. Let's try to draw our recursion stack, how it will look like. Let's say we have these matchsticks and we have to prepare 4 bundles where every bundle should have a sum of equal to A. Let's say first bundle is having sum S1, second is having S2, which should also be equal to A. Second bundle is having sum S3 and fourth bundle is having sum S4. All should be equal to A. And what is the value of A? That is equal to parameter divided by 4. So initially, what is the value of these sums? So these sums are empty. So S1 is equal to empty, S2 is equal to empty, S3 is equal to empty, which is 0, S4 is also 0. And we have to do is grouping these matchsticks into these 4 like bundles. Let's say this is the bundle, and if I put first matchstick in this bundle, the sum will equal to S1 equal to 1, and the rest of the sum will look like this. S2, S3 and S4 will be 0. Or if I put this matchstick in this bundle, here S1 will remain 0, S2 is equal to 1, S3 is equal to 0 and S4 is equal to 0, and so on. So for every matchstick we have 4 possibilities. Either it can be the part of first bundle or second bundle or third bundle or fourth bundle. After that we will move to the second matchstick. Second matchstick is also having 4 possibility. It can be part of first bundle, second bundle, three bundle or fourth bundle. If it is part of first bundle, S1 will be incremented. If it is a part of second bundle, S2 will be incremented, and so on. For the third bundle, S3. For the fourth bundle, we have a sum S4. So what we are going to do is we will make 4 recursive code for every matchstick, and we will keep on tracking whether there is any possible combination where S1 is equal to S2 is equal to S3 or is equal to S4 equal to A. If we are able to divide these matchstick in 4 sections, so what we will do is we will see whether there is any division possible where we are able to divide these matchsticks into 4 bundles where every bundle will sum to this A specific value. It means that we have divided these matchsticks into 4 sections, and all these 4 sections can lead to the edges of our square, and it's clear to us that we can form the square. Otherwise we just return false. But here we have to think of a way there will be a lot of pruning. So if at any step S1 is getting bigger than A, so we can directly return false. It means that possible combination will not lead to our answer. So every bundle sum should be from greater than 0 to less than equal to A. This is we have to keep in mind. And apart from that, one pruning we already discussed, that is the sum or not the edge is equal to perimeter divided by 4. If this is not a perfect integer, we can directly return false. That is perimeter divisible by 4 should be equal to 0. That is also one pruning. The second pruning is like this, that at any moment the sum should lead to 0 to A. So how we are going to solve this problem is, let me just write a prototype of solution function. So for the solution function, we have this array 1 1 2 2 2, and I will be writing an index to track my current matchstick. So I will be starting from the 0th matchstick and I will be going till n-1th matchstick. So for that I will be taking idx integer index, and for every section S1, S2, S3 and S4, these are the sum of every section. So these sum I will track S1, S2, S3, S4. So at any moment, if all of these sums are equal and equal to A, if they are equal, they are definitely equal to A. Otherwise, because I will add the pruning for that. So but we have to also be sure that we have used all the matchsticks. If we have used all the matchsticks, the index would definitely be equal to n. Then I will check if S1 equal to S2 equal to S3 equal to S4. If that is the case, we have to return true. Otherwise, we will just return false. Else, return false. Otherwise, we have to make 4 calls. That is solution idx plus 1. First call, second call, third call, fourth call. In the first call, I will be adding ith matchstick to the first bundle. In the second call, I will be adding ith matchstick to the second bundle, then third bundle, fourth bundle. If I am adding ith matchstick in the first bundle, the first bundle sum will be incremented. In the second call, the second bundle sum will be incremented. S2 plus array of I or idx. S3 plus array of idx. S4 plus array of idx. Array is the matchstick array. So at every step, we are making 4 calls. And among these four calls, if I'm getting, I will check a if condition. If solution of this giving an answer, or solution of this, or solution of this, or solution of this. If any one of this call is giving me a true, I will return true. Otherwise, I will return false. So this should be my basic prototype of this problem. But here we have discussed that we have to make one more pruning, that S1, S2, S3, S4, any one of value sum should not exceed a value. What is a? A is the maximum, A is the size of our square. Okay, now I think it is clear to you. Here we will be able to get the answer, but when I submitted this problem, I faced one TLE to my code. So what was that? That was like when the matchsticks are in the form of something like this: 1 1 1 1 1 1 1 1 1 1 192. If it is in the form of like this, so what should be the square value? 1 2 3 4 5 6 7 8 9 10 and 192, or you can say 190. So it is 200, and the square value is a is equal to 50 50 50 50, and we are making a call and we are incrementing S1 S2 S3 S4. So here what is the a value? A value is 50. That is, using these matchsticks we can form a square whose value, or you can say whose edge, can be equal to 50. And what we will do is we will try to figure out the possibilities. So we will try to adding 1 to these for possibility, 1 to these for possibility, 1 to these for possibility, and in the end, in the last index, I will get to know that if I add this to any one of the set, I won't be able to get the solution. So I got to know that on the last index, I'm figuring out that my edges are getting more than 50 in every set. So it means the pruning will reject the code and I will get a return false. So here S1, S2, S3, S4 should not cross A. So what I have to do in this case is, if I sort in descending, if I sort these matchsticks in the descending order, so 190, 1, 1 and so on. So if I'm picking the first edge, S1, add it to S2, or you can add it to S3, or you can add it to S4. You can add it to any set. If you are adding it to any set, every set value is getting equal to 190, which is more than our A. A is 50 here. S1 is greater than equal to A, S2 is greater than equal to A, S3 greater than equal to A, S4 greater than equal to A. So all these code will be discarded and I will get false. So here at this step, we are terminating our cases. So here, this was the pruning, where I did the sorting of the matchsticks in the decreasing order. Otherwise you will experience TLE. Okay, so this was a pretty good problem. where using these matchsticks we have to form a square, and there involved a lot of edge cases and the pruning conditions we have to implement. Otherwise, its backtracking solution is going to give us TLE. Here, let's say n is the size of these matchsticks array. So at every matchstick we have four possibility. Either it is a part of first edge, second edge, third edge, or fourth edge. So every step we have four possibility. So four possibility for first step, four possibility for second step, four possibility for third step, four possibility for nth step. So in total it is equal to 4 raised to power n. This is going to be the time complexity. And what is the space complexity? Space complexity will be equal to our recursion stack, and recursion stack will go till on depth. Okay, because n is the size of this array. So space complexity is our recursion like stack, and the time complexity is 4 raised to power n, because at every matchstick we have four possibilities. Now let's have a look on our solution, like what I did here. Here this is our matchstick array, and we have to use every matchstick to form our answer, and we have to make a square using these matchsticks. So first of all, I have to know that I have to know the parameter, whether this parameter, what is the value of this parameter, that is sum of all the matchsticks, and whether the square, making a square, is feasible or not. So first of all, what I did is I took the sum of this matchstick to find the parameter, and I checked whether it is feasible or not to form a square, whether we can form the square or not. And this is the length of like valid edge length, that is a. What is a? A is equal to parameter divided by 4. Okay, here what I did is I just sorted all of these edges, or you can say all of these matchsticks, in the reverse order. So first of all, I'm going to pick a matchstick of larger value, because there can be the cases where we have smaller matchsticks, and in the end we are having a very large matchstick that cannot be fit in any of the edge. So first of all, we have to sort it in the reverse order, and then I wrote our magic function, that is our solution function. In the solution I have passed the index and sum of each block, because in the end we want each block sum to be equal to a, or you can say every each sum block should be equal in value. So this is our solution function. First of all, I wrote some pruning, where s1, s2, s3, s4, any of the edge is going beyond value a. In that case, that is going to be a false directly. Otherwise, we have our positive edge case, or you can say terminating case, where edge index is equal to list of size. It means we have used all the matchsticks, and after using all the matchsticks, if sum of each group is same, it means we can form a square easily, otherwise return false. And these are the four calls we are making at every step, that every matchstick at index idx can be a part of s1 or s2 or s3 or s4, like this. If I'm using that matchstick, I'm going to increment the index anyway. Index is going to be incremented every call, and in every call I'm considering that matchstick to be a part of first group, second group, third group, fourth group. If all the groups are giving me answer as false, if you are not able to that is the idx matchstick is not able to be the part of s1, s2, s3 and s4. If this idx matchsticks cannot be fit in these four group, it means we cannot proceed further, because we have to use all the matchsticks. And if idx matchstick is not able to use, so we will just discard our every call and we will return false. So this was the call. This was the solution, where the time is 4 raised to power n, and the space is order of n. It was a very good question, so I felt like sharing with you. And it was like asked with me recently. I recently experienced this problem in the Microsoft interview question, and I solved using the same approach. but I was missing a couple of like pruning cases in the end, but later on I have figured it out. Okay, hope you understood the problem. Thank you guys. Bye bye.